Welcome to my channel Phi Concepts CHM. This video is about crystal structures. This is the sixth part of the series of crystal physics. We will see about the diamond structure. The cubic structure of diamond is obtained by the interpenetration of two FCC sublattices along the body diagonal by 1/4 cube H. So we can imagine about one sublattice and its origin at 0, 0, 0. So this is the origin 0, 0, 0. And the other sublattice has its origin 1/4 of the lattice constant A along the body diagonal at A by 4, A by 4, A by 4. So the second sublattice starts from here. This atom is at A by 4, A by 4, A by 4. You can see that these are the corner atoms which are denoted by C. The face-centered atoms are denoted by F. This is the face-centered atom. This is a face-centered atom. This is a face-centered atom. And this is also a face-centered atom. And also there are 4 body atoms. That is shown by the numbers. One, 2, 3 and 4. So a unit cell has 8 corner atoms, 6 face-centered atoms and 4 atoms located inside. Now we will find the atomic radius. We'll consider the projection of atom Y onto the bottom surface at Z. So this is projection of Y falling on the bottom face at Z and joining X and Z. So this small part is indicated here. These two sides are A by 4. Here also this height of Y atom from Z is A by 4. And both the atoms X and Y are touching each other. So the nearest neighboring distance is 2r. So consider this triangle XZT. Apply the Pythagoras theorem and find XZ square. So XZ square is equal to A by 4 the whole square plus A by 4 the whole square, and that is equal to A square by 8. Now consider this triangle XYZ. This is a right angle triangle. So XY square is equal to HZ square plus ZY square is equal to XZ square we have got as A square by 8, that you substitute, plus A square by 16 is equal to 3A square by 16. Now XY square is 2r the whole square. This is 2r. 2r the whole square. which is 4r square. So that you can substitute here. So 4r square is equal to 3a square upon 16. You get the atomic radius r is equal to root 3 into a divided by 8. Now we will find the packing factor, which is the total volume occupied by all the atoms in a unit cell divided by the volume of the unit cell. As there are two sublattices of FCC structure and one FCC structure has 4 atoms, so two FCC structures will have 8 atoms. So 8 into the volume of one atom is 4 by 3 pi r cube divided by the volume of the unit cell. One side has length a, so the volume of the cube is a cube. You can substitute a, as we have got the atomic radius, that formula you can rearrange and substitute a as 8r upon root 3. So this comes as 0.34. That means the carbon atoms in the diamond structure occupy 34% of the unit cell. So hence diamond is the most loosely packed structure. Next is the cubic zinc sulphide or the zinc blende structure. It is identical to the diamond structure, except that there are two interpenetrating FCC sublattices made up of different atoms. One is that of Zn and the other is of S. So the carbon atoms are replaced by Zn and S atoms. Zn is on one FCC lattice and S is on another FCC lattice. These are the examples. These materials, they exhibit this kind of structure. Next is the sodium chloride structure. Again, it is made up of two FCC structures. The red one is the sodium atom and the green one is the chlorine atom. The chlorine atoms are placed at half of the edge of the unit cell along each axis. So it is formed by the interpenetration of two FCC sublattices of sodium and chlorine. These are the coordinates of the chlorine ions and these are the coordinates of the sodium ions. Now we'll find the coordination number. Each sodium atom is surrounded by 6 nearest chlorine atoms. Same way, each chlorine atom is surrounded by 6 nearest sodium atoms. Like if you consider this sodium atom as the center, then it will have 6 neighbors. This is the center. If you consider this sodium atom as a center, then it will have one first neighbor opposite to this, second neighbor, then third neighbor, this is the fourth neighbor, this is the fifth neighbor, and this is the sixth neighbor. So that way there are 6 neighbors for one atom. So each atom is shared by 6 nearest neighbors of opposite kind. So the coordination number capital N is equal to 6. Thank you for watching my video.